Hello everyone. Now I am going to explain about
Direct shear test on given specimen under the double shear. What are the equipments required in this experiment? It means the UTM with a double shear check and vernier caliper and test specimen. The UTM machine capacity is 400 kilonewton and range is 0 to 400 kilonewton. What is the precaution will take at the time of doing in this experiment? The inner diameter of the hole in the shear stress attachment is slightly greater than that the specimen. In direct shear test, the shearing stress is considered as uniformly distributed over the entire cross section. The shear force is applied by a suitable test rig. Two different case of shearing may arise here. First one is a single shear, next one is a double shear. In single shear occurs across a single surface. So see the single surface, and in double shear occurs across the two surfaces. Knowledge of shear failure is important while the designing any structure or machine component. Shear force causes the surface to go out the alignment with each other and thus the material fails. The shearing force in each section is P is equal to F by 2. It can be concluded that average shearing stress is the maximum load divided by the combined sectional area of the two planes. So double shear strength, the formula here mentioned P by A is equal F by 2 by A is equal F by 2 into A. Shear strength of the specimen is determined by inserting a cylinder specimen through a round holes in three hardened steel blocks, the center of which shall be pulled or pushed between the other two so as to shear the specimen on two planes. In this test, a suitable length of cylinder specimen is subjected to double shear loading using a suitable test rig in testing machine under the compressive load or tensile pull and record the maximum load P2 fracture. The speed of testing or the rate of separation of the crosshead at any moment during the test shall not be greater than 10 mm per minute. So, what is the shear stress? It is produced in a body when it is subjected to equal and opposite forces spaced at an infinite decimal distance tangentially across the resisting section. So normally the shear stress how can we express means shearing force by area of resisting section. Generally, it is difficult to produce condition of pure shear as some bending effect is likely to occur due to the shearing load resulting in equal and opposite forces at the small distinct. This is a test specimen. The specimen shall normally be a full cross section for cylindrical metallic products up to including 25 mm in diameter. In the case of cylindrical product over 25 mm in diameter, the samples may be turned down to a specimen of 25 mm diameter for testing. According to Indian standard, minimum length of specimen should be twice the diameter. The maximum length of specimen is not specified as has no particular effect on the test result. Shear strength of the typical metals are of the order of about 60 to 80% of their ultimate strength in tension. For example, the shearing strength of 60 KSI steel, ultimate strength about 70 to 75 KSI, and the yield strength is 60 KSI.
or on and off switch, and this is hydraulic supply. So in this control unit is connected to in this jack. Okay, when you are going to apply the load, what will happen in this elevator screw will be lift up or lift down with using with the help of in this button. You can move up or move to up or downward direction. This is the main gauge. Okay, the capacity is 400 kilonewton. but now I am fixed 400 kilonewton. This is a null position. Here mentioned, here shown there are two different pointer, one red and white color. The white color only indicate at the time of during that at the time of during load, indicator will be moved like this. Okay. uh, in this white pointer is guided to in this reply indicator. Okay. Here per division, see, so 0.8, so per division is zero point 0.8. Okay, so per division is 0.8. With respect to fracture load, we can observe the values from in this gauge. Okay.
Now I am going to start the experiment. This is the shear test apparatus. This is UT machine already told. The setup is fixed on UTM table. This is the overall control unit already mentioned. Okay, what is the procedure? The first step is to measure the diameter of the hole accurately, and second one is to insert the specimen position and grip one end of the attachment in the upper position and the other end is the lower position. Okay, now switch on the main switch on the universal testing machine. The elevator screw is moving downward direction. It gently contact to specimen. Now, now, okay, bring the drag indicator to contact with the main indicator. So now we note down the load at which specimen shears. So now the gradual load is applied on specimen. Now note out the value from dial gauge. Note down the load at specimen shear. Now note down the load. So now stop the machine and remove the specimen from UTM. This is the failure failure specimen. The specimen is here. Then note down a shear load taken by specimen at the end of the failure.
Now I can do calculation part, observation and calculation. Diameter of the given specimen is 6 mm, and after complete the experiment, the shear taken by the specimen at the end of the failure load P is 1500 kg. See this is a tabulation for direct shear test. First column is represent diameter of specimen in mm and area of the cross section pi a is equal to pi d square by 4. So use with the formula only we can calculate area of cross section, and failure load in kg is recorded 1500 kg after complete the experiment from UTM machine, and double shear strength Newton per mm square. Last column only we need to find by using the help of this formula P into 9.81 divided by 2a. This is calculation part area. First calculated the area of cross section A. The formula is pi d square by 4. D means dia of given specimen. The specimen diameter already measured with help of vernier caliper. The dimension value is 6 mm. So the final answer for area of cross section the given specimen is 28.26 mm square. Next, go for double shear strength is equal to P into 9.81 divided by 2A. P is denoted failure load. The 1500 kg is already observed from UT machine. Multiply into 9.81 because it is Newton per mm square is unit for double shear strength. So 1500 into 9.81 divided by 2 into area of cross section already measured, calculated. So 28.26. The final answer is 260.35 Newton per mm square. So the final result, the shear strength of given specimen is 260.35 Newton per mm square. Okay, thank you.